All right, so today we're going to talk about class variables, but just a quick review. I wanted to talk about these attra accessor and attra reader, and the other one was called attra writer, that are methods written in Ruby that actually write Ruby code. So they write code for you. They allow or they create getters and setters for you. So this attra accessor, given this symbol called description, will create three different things for you. It creates the getter program for the variable called description. It creates a setter for the description, and it creates, what's the last thing? The instance variable called description. So what this does is it creates attra accessor on description would be the same thing as writing out description, return at description, and this is what it actually creates. It writes this code for you, and it writes the description equal sign method with some value that sets the instance variable, and it creates the instance variable itself. Now, it does not assign it on the initialization. It doesn't do anything with the initialization. So this, you would still have to do this code here if you want to save that value or allow them to initialize it from the outside world on creation of the object. All right, so that attra accessor for that symbol creates these lines of code for you automatically. The attra reader creates just the getter, so it would have created just these lines of code. The attra writer creates just these lines of code. And the reason we have those is that sometimes we only want to have, we don't ever, for instance, on the ID, we never want the user to be able to change this ID. That's going to be set on initialization. It's like a database auto-increment ID column in a table. You can never change that. You can't change the ID. You can delete it, add a new one, but you can't change the ID. So this lets us read the ID. We can get the ID out of the database column, but we can't set it. So that's the reason we have these different types of values. These are the ones used most often. I mean, the attra accessor is the one used most often, because most of the time we have variables that we want to set and get at the same time. So that's just a quick review on.
Question.
Yep.
I'm reluctant to even ask, but can you explain the colon thing again?
Okay, that's a symbol. It's a special type of data inside of Ruby that has no real value except for the name of itself. So there is nothing, it's like a constant string is the way a lot of people describe this. It's a constant string that you can't change. It always will equal description, and it's used, it saves memory because when you create a symbol, you only have one copy of that string in memory. Okay? This description now is a symbol. It's a thing in memory, and it takes up just enough room to store this string itself. But if I had a program down here and I said A equals description, every time I use this value in quotes, Ruby has to create a new memory location to hold that string. Whereas, and so it takes up a lot of room if I have a bunch of those. Whereas if I have a symbol, that takes up one location, and I can use the colon name of this thing, the symbol, throughout my code, and it doesn't use up any more memory. It refers back to that same instance of the symbol. So it's a memory-saving device. It's faster. It doesn't have to create a string every time. And the methods that I have available to me for symbols are, I can create a symbol like description, and A has the value of the symbol itself. it is a symbol. I can say a.2s, and it returns the symbol as a string representation. So I can use that to print out to a screen. But in memory, it's still taking up just the original description symbol itself. And I can also change something like Dave to a symbol. So I can convert to and from a symbol. I can print out the symbol. And that's really it. There's nothing else I can do with it. It's just a way to describe something. It's a constant variable that I can use. I mean, it's constant string, not a constant variable. That's kind of a oxymoron.
Using it in your program there. It's creating some getters and setters for description.
Right. So it uses this name. So the code behind the @accessor is that it's actually writing out the value def, and it takes the symbol and converts it to a string so that it's the actual name here. And it uses the symbol again and converts it to a string through some Ruby magic code. And so it actually creates this code here from this one value. So it's just a way of identifying things. It's a constant. I can't change that. It will always be called description. I don't know how else to describe it than that. It's a weird concept.
How does it equate to anything that's in like real poker?
As a constant string. That's the only thing that we can say. If you created a constant string in C#, you couldn't modify that value, right? It takes up one position in memory, and you can always refer to it. You could print it out from the screen. That's the best concept I can come up with. Okay. In Rails, it's used constantly because it takes up a lot less space than creating a string every time. So it uses significantly less memory. When you have a bunch of these, you're going to save a lot of space. So I know it's a weird concept to get across. Constant string, that's the only way I can come up with. All right, any other questions? Hopefully I've confused you enough there. All right, I want to talk about class variables now a little bit. What we have so far, we have these instance variables, right? Now, an instance variable is global to the object itself. So this description is the same whether I'm returning it or printing it out down here. As soon as I set that value, it's available throughout the object. So when I change it, that value gets changed for that object. So if I have a different thing, like down here, I created a shirt object, and its description, its instance variable, is the string shirt. When I created this pants variable, its description variable is called pants. So they have different values assigned to them because they're in different objects, right? Pants.description is different than shirts.description. They're different variables. They're different because it's a different instance of the object that was created from this blueprint. Remember, the cups coming off the line, my coffee cup is different than the next one coming off the line. And one coffee cup might hold milk and one might hold coffee. They have different values inside of the object that we've created from it, right? So each instance is an object that came off of the assembly line based on the blueprint of the class that we used, right? Everybody with me on that? So every object has different instance variables associated with it. They do not cross over. I cannot, if I change my pants description, does it affect the shirt's description? No, it's different. They're different objects. If I pour coffee into one coffee cup, does that change the coffee in the another coffee cup? No, because they're different objects, right? So a class variable destroys all of that. All right? A class variable is designed to be global across all objects created from that same blueprint, from that same class. All right, so if I create a class variable and I change it, it changes. The easiest way to think of it is that it changes it in all objects that were created from that class at the same time. Okay, so if I change one class variable, it changes across all the objects that were ever created from that class template. All right, so it's a global variable across all classes, all objects created from that class. Sorry. All objects created from that class. So to differentiate those, we use a single @ for an instance variable. We use two @s, two @ signs, and a name to create a class variable. So if I can create a class variable called store, okay, fine, store. All right, so I can create a store and I can assign it to something like Dave's store. All right, so that variable now is available to all of the objects that were created from this class. So if I go down here and I print out at the very end, let's put my shirt dot inspect and my pants dot inspect. Remember that the 2S changes how my inspect works? So let's change that. So for now, it doesn't give me my values, does it? So the inspection doesn't do that. I thought it did. There you go. That's what you get for thinking. All right, so in order to get this value out, I can write a getter for my store value. All right, so how would I write a getter to get this value out of my method, out of my class? I cannot use a shortcut on class variables. What do I want to call it? Store, maybe, might be a good one, right? And I'm going to return the value of my instance variable. All right. So when I print it down here, I can call the method store and my pants.store, and we'll see what's changed here. Okay, they're exactly the same. They are the same variable across both of these objects. All right, so let's write a setter for my instance variable. How would I do that? All right, good. So you guys write a million of these now, right? You should be able to write these in your sleep. So if I change that, let's change one of them. Okay, so I'll change the shirt.store to be equal to Joe's store now, and then let's print the store back out again. And what would you expect to have happen? They both should be changed, right? All right, so I changed it in the shirt, but because it's a class variable, it changes it in all objects that were created from that class, right? So I now have, I changed it once, it affected my shirt and my pants object the same. So that one class variable is available to all of the objects that are created from that. Okay? Any questions on that? Yep. Something that you would want to have global across all objects created from that. Okay, so in this case, remember we talked about how this ID, when I made you do this assignment last quarter, what was special about this ID? It had to be unique, right? So I can't just create a random number when I initialize this. I have to create a random number that's not been used before. So how would I store that? How would I know that it hasn't been used before? I need a class variable to store all the ones that have been used so that I can check against that list and create a new one if it hasn't been, right? Or I could use, like in an auto increment database, I might store the value of the last item created. So like the first time I create an object, it's going to be 1. The second time I create an object, it's going to be 2, etc. All right? And so let's do that way for now to start with. Oops, mixing my languages. So if I create a class variable called well, let's call a new one called ID. IDs. How about, let's call it last ID. How about that? That sounds better. Last ID used. And we'll initially set that to be 1. All right? Now, the problem is that this initialize method gets called for every object that gets created, right? So if I create a shirt, this last ID is going to be set to 1. Then if I create a pants, this last ID is going to be reset to 1 again, right? So I can't just assign it arbitrarily. I have to have a way of initializing it when the class is created. So let's see. Now, I'm not sure if this is actually going to work. I know they changed some stuff in the latest version of Ruby, so let me see if this works first. If I assign it in the class outside of the methods, let's see what happens. See if that's actually going to work. And I need a way of printing that out, so I need a getter and a setter for my ID. Actually, I only want a getter, right? We don't want to call it get. We want to call it last ID, and we'll return the value of last ID. All right. You don't need it, but I'll put it in to be consistent. Stop. All right, so it is set to 1. So I'm creating it on the first time that the class is exercised. So this should be 1. And instead of randomly creating an ID, I want to create an ID that is the last ID plus 1, right? And then I want to increment my last ID so that the next object that gets created is going to have a new ID. So let's see what happens now. All right, so my last ID ended up being 3. No. What this did was take the value of last ID, add 1 to it, and stuff that sum into my ID. It didn't change last ID. Okay, then I take the last ID and I add 1 to it and stuff it back into last ID. So this is the only one that changed the last ID value. So down here in my code, I must have created 3 instances, right? I only created 2. And so I'm off by 1. Isn't that common? Why am I off by 1? Right. So I need to start my last ID as 0. And now I have 2. Okay, so I've created 2 objects. If I look at each ID, let's, am I printing out the ID? Yes. So let's change my 2s back away from the inspect. And I can see that my shirt here is 1. my pants are 2, item 2, and that doesn't change throughout the whole thing. If I create new ones, the next new object that I create is going to have an item of 3. Does that make sense so far?
Why is your last one 2?
That was the last ID that I used.
Can you insert on that one?
I know, that's already used. It's the variable. Think of the variable name. It's the last one that's been used. And when I create one, I'm adding 1 to the last one that I've used when I create a new object. So the next item that I initialize is going to be 3, which is correct, right? So let's create a new one at the bottom. Let's create a new, socks. Item.new, we'll call it socks, and their price was $4.99. And now if I print out my last ID, and if I puts out my socks, we'll see what we got. Okay, so my socks has the ID of 3, and the last ID that I've used is 3. Yes? Oh, okay. Yeah. All right, any questions on that? Yeah.
With that random number, what happens if you have 900 items?
Then your program crashes, right? I mean, you're never going to. Actually, the way we wrote it last quarter, you loop through until you find one that is unique. And if you have 999 used, that would be an infinite loop, right? So obviously that's a small database. Right. You'd be in trouble. That's right. So you got to think about that. This was for just a quick idea. Databases go up to however big your column, that data type is for that column. If it's 64,000 maybe, or if it's 64 bits, you got a big old huge number you can put in there. So it just depends how you make the data. In Ruby, what's nice is because this is a number type object, if it gets big enough, it will change the data type into a big num data type, which can hold an infinite number. It's not dependent on the architecture of the computer. That's one nice thing about Ruby. It just is really cool in those concepts. I don't have to limit this to 64K or whatever. I can just let that go off forever, and it would keep adding 1 to it, and it would still work. All right, any questions about this class variable concept? All right, so I used it with a number here. If I wanted to use this randomness here, how would I change that? How did you guys do it in last quarter? With an if statement, okay, but what did you store? How did you know that something was used already?
Put it in an array.
You put it in some structure to hold it, right? So an array would be work really well. So I could change this around, and instead of last ID, I could have a class variable called used IDs. How about that? And we'll initialize it to an empty array. Okay, and so then in my code down here, instead of doing this, I need to generate a number, right? And then check to see if that number is already in my array. So what do I do with that? I say if my ID, what? How do I check to see? Okay, no. I have to look in my array. I have to say in my used IDs, dot include, does it include the value that I just created? If it does, then I need to generate a new one. All right, now that only does one. So how would I make this work? A while, very good. So I could say while this is included, that means what? It's already been used. I need to generate a new one. All right. Then at the end of this loop, my ID is going to be some random number now that has not been used. All right. So when I create it, and I have a good one now, at the end of this loop, I need to add that new good one to the array so that I don't generate that new one again, right? So how do I add that good one to my array? What he said. All right, so the only difference here is that I'm using these @ signs to reference these class variables, and the single one to reference my instance variable. So you got to remember to use those when necessary, because that becomes part of that variable name. So now that one takes the one that I just created that was good, I'm outside of this loop, stuffs it back into my use IDs, and I continue on. All right, so now let's run this and see if it actually works. Yeah, I need to change because I'm not using my last ID anymore. Let's print out use IDs, and we'll print out use IDs dot join with something like that. That's an array, right? And I can call array methods on it, and so I'm going to return a string that will tell me what values have been used already. And I got a bug. Look at that. Undefined method last ID. So I messed up, and down here I want to print out, instead of use that, I'm going to print out my used IDs here instead. All right, so now every time I print it, I get a new ID for my shirt, a new ID for my pants. It's random, 3 digits. And I created my socks. Now I've got socks, and these are the 3 random IDs that are stored in my class variable. And again, that class variable is available to all of the objects that were created from that blueprint. It's global across all objects from this that were created from this class. Whether they were created before or after, it doesn't matter. That's always is always going to be there for every object. All right? Any questions on any of that? Isn't that fun?
Yes. Just like fun.
Just like fun, but not quite. Yeah. Closely resembling fun, but not really. All right. So